Okay, class, today we're going to talk about compound inequalities. We've got two parts to this lesson. The first one we're going to talk about are inequalities that are joined by the word and. There's also compound inequalities joined by the word or. Today we will concentrate on compound inequalities with the word and. So let's look at an example here. Write a compound inequality that represents each situation and then graph the solutions. Okay, all real numbers that are at least -2 and at most 4. We're going to start off by writing two inequalities. So we need to write an inequality with values that are at least -2 and then at most 4. So we're going to write two different inequalities. We've got x and -2. Just like we did on single inequalities, we're going to put a space in between the variable and the number, and then we're going to decide which way that inequality symbol needs to go. If we want numbers that are at least -2, that means at the very least we want them -2, but they could be bigger than that. So we would do greater than or equal to -2. And then at most 4, okay, we put the x in the 4, and if at most 4, that means it's got to be less than or equal to 4, because at most it could be 4. So that means it has to be less than or equal to 4. So this is a compound inequality. We're going to connect these. Okay, we're going to make them into one inequality. Here's how we do it. We put the x in the middle. We're going to line up the numbers with the x. The smaller number is -2, so I'm going to put that on the left, and I'm going to leave a space right here for an inequality symbol. And then I'm going to do the same thing on the other side. I'm going to put a 4 and leave a space for an inequality symbol. And this is the part you have to be very careful, because now we're going to go in and put in the inequality symbols. In between the x and the -2, the mouth of the inequality symbol is facing the x. So we need to flip that inequality symbol around, and the mouth still needs to face the x. So we put it in just like this. This is less than or equal to x. And then again, the mouth is facing the 4, so we need to make sure the mouth faces the 4. So we have this right here is our compound inequality, where x is at least -2 and at most 4. Now we're going to graph the solution. So what you're going to do on these, I want you to draw your number line, and I want you to put -2 on your number line, and I want you to put 4 on your number line, and then pick one number in the middle to stick a number in there. So we'll put 0. We'll put 0 in. 0 falls about right here. All right. So then what we need to do is we need to go look at -2 and 4. Both of the inequality symbols are or equal to. So that means they're going to be closed circles. So I'm going to put closed circles on -2 and 4. And if we think about an and inequality, we wanted values that were at least -2, so that means bigger than -2, so that would go kind of this way. And then we wanted values at most 4, that means we want less than 4. So the and inequalities, they're always going to come together like this. You're going to have your two endpoints, and then they're going to connect between the 2 points. And that is a compound inequality. It's an and inequality. We call it an and inequality when we can put them together like this. You'll see the difference in an and an or on the next video. Okay, let's look at a problem about temperatures here. Today's temperature will be above 32, but not as high as 40. So again, we're going to set up our two inequalities here. Temperatures will be above 32. That means x, or actually let's create a variable for this. We'll call it T for temperature. T will equal temperature. So we want the temperature to be above 32. So we don't want it to be 32, but we want it to be above 32. So that means it's greater than 32. And then we also have T is, that's a J. Let me fix that. Okay, so we also want T to be not as high as 40, so it needs to be less than 40. So there's our two inequalities, and then we can put them together with the word and. So we get T is greater than, actually, I'm sorry, we're going to put T in the middle. T in the middle, our lowest number is 32, so we'll put it on the left. 40 is our biggest number, we put it on the right. And then we fill in our inequality symbols appropriately. So if you look at the T and the 32, the mouth is towards the T. So we're going to put the mouth towards the T. And then on T and 40, the mouth is towards the 40, so we're going to continue to have the mouth towards the 40. Here is our inequality. And then again, to graph this, we draw our number line, put 32 on there, and let's put 40 on there. And then I'll fill in somewhere in here, we'll put 36 is approximately in the middle, 36. And then if you look, this time we don't have the or equal to, so we have to do open circles at 32 and 40, and then we connect it in between. And that's how you graph an and inequality. All right, so let's go to example 2. Solving a compound inequality containing and. So looking at this problem, we have negative 4 is less than r minus 5, which is less than or equal to negative 1. All right, now here's what we do. We've got two inequality symbols. We're going to draw a line at each inequality symbol. So instead of, on regular equations, we have two sections. On a compound inequality, we've got three different sections of an equation. The goal is to get the variable in the middle by itself. So whatever we do to the middle, we have to do to the two sides. So to get r by itself, we got to add 5. And since we added 5 here, we have to add 5 on the right, and we have to add 5 on the left. So those cancel. We get negative 4 plus 5. That's going to be 1, which is less than r, which is less than or equal to negative 1 plus 5. We get 4. So we have values of r that are greater than 1, but less than or equal to 4. So if we're going to go graph this, we're going to draw our number line. We'll put 1 on here, and we'll put 4 on here, and then we'll pick a number in the middle, or somewhere in there. We'll pick a 2. All right, and then we need to figure out our open and closed circles. At 1, there's a less than, so we leave an open circle. We put an open circle at 1, but then at 4, it's an or equal to, so we put a closed circle, and then we connect the dots. So this is the graph to our solutions. This describes all the solutions that make that inequality true. All right, let's do letter B. Letter B, we want to get negative 3n by itself, so we're going to actually subtract 1 from all sides of the inequality. So we get 6 is less than negative 3n, which is less than or equal to 13 minus 1, we get 12. All right, now we have to do a little bit more to this one because we now still have a negative 3 attached to the end. So if we divide all three sides by negative 3, okay, we're going to have to flip our inequality signs because we're dividing by a negative number. And if you remember, that's the rule. When you're dividing by negative, you have to flip your inequality symbol. So 6 divided by negative 3 is negative 2. So negative 2, and then I'm going to go ahead and flip around my inequality symbol. We get n, and then I'm going to flip around the other one. And then 12 divided by negative 3 is negative 4. Okay? So I have to flip those inequality symbols. That is absolutely important. Now, on the number line, you need to be careful because the bigger number is on the left and the smaller number is on the right. Negative 4 is, in fact, smaller. So we're going to put negative 4 on the number line, negative 2. All right, we'll just fill in, I'll just put negative 3 right here. All right, so then we have an open circle at negative 2 because of the greater than, it's not or equal to. So we have an open circle at negative 2 and then a closed circle at 4. Connect our dots, and that is the graph to the solutions of the inequality. Okay, example 3 on the back side we're actually going to fill out as a class tomorrow, or actually this is the weekend video, so this will be when you come back on Monday. We will do example 3 on your notes, which is on the very back, so just save that. Thank you for listening.